Hi friends, welcome to my another video. Today in this video, I will discuss about the protection angle method for the lightning protection design. This is the part 5 video in series of lighting protection system designing. In last part 4 video, I already discussed the risk assessment involved for the lighting protection system. What are the different classes of the lighting protection system? We already discussed about the rolling sphere method and the mesh method for the lighting protection system. In this video, I will deeply cover about the protection angle method for the lightning protection system. So let's start this video. If you remember the rolling sphere method which I discussed in the earlier part, you came to know that we are assuming one imaginary sphere based on the class of protection. For class 1 protection, we are assuming the imaginary sphere of 20 meter radius, but for class 2 protection, we are imagining an imaginary sphere of radius 30 meter. So protection angle method is a simplified method of the rolling sphere method. If you remember, in the last rolling sphere method, we used complex formulas in order to calculate the number of air terminals for a particular project. This protection angle method is a mathematical simplification method of the rolling sphere method. Okay, so what is the important point to note in the protective angle method is that we have to suppose there is a air terminal here which is shown in the golden color. We have to cross a line, okay, in such a manner that the area of this green color and the area of this red color will be equal. So the angle which is made when we draw a angle between the air terminal in such a manner that the area in the green color and the area in the red color is equal, then that angle is called the protective angle method. Hope you are very clear with this. In the rolling sphere method, we assume one sphere of radius based on the class of protection. Like for class 1, it will be 20 meter. For class 2, it will be 30 meter. For class 3, it will be 45 meter. And for class 4, it is 60 meter. In same way, for the protection angle method, we have a particular height for the lightning arrestor or air terminal. Based on the protection class, the angle will change, okay, and whichever area is covered by that air terminal, that area is called a protection zone. Suppose any equipment or any house is under this cone, imaginary cone, then that house or that equipment will be considered as a protected from the lightning protection system. But suppose if any home or any equipment is crossing this protection zone, then we can say that equipment or house is not protected through the protection angle method, as it is crossing the protective zone made by this protection angle method. Hope you are very clear with this. Suppose I have a small home and the class of protection for this home is class 1, and let us consider for a while this angle is 45 degree. Okay, so we install one air terminal with this 45 degree angle. It is protecting this home. So this home is protected as it is lying under the cone area which is made by this air terminal. But for example, consider this time the angle is not 45 degree but it is 30 degree. So what will happen? 30 degree will be somehow this one. Okay, this will be the angle 30 degree. When the angle will be 30 degree, the partial part of the home, this part of the home is outside of the protection zone for the protection angle method. So we can say that this home is not protected. But I will give you one more example. I have to protect this home with the 30 degree angle itself. Okay, 30 degree angle itself. So we have one solution. We have to increase the air terminal rod. This is the 30 degree protection when the height of the air terminal is this one. But suppose I increase the height of the air terminal, then the angle will be same, that is 30 degree, means it will be a parallel line. So you can see that with the same angle, when we increase the air terminal height, this home is protected. But with the lesser height, this home was not protected through the protection angle method. So in order to protect any home or any equipment, what we have to check? We have to see the angle of protection and the height of the air terminal. But in all cases, to increase the height of the air terminal is not possible. Why? Because there is a limitation to have the height of the air terminal, as well as when we will increase the air terminal height, the cost will be more. In that case, what we have to do, suppose this is my home, okay, and I have to protect this home through the protection angle method. Then what to do? We have a limitation to have the air terminal, and suppose this angle is 45 degrees, so it is only protecting my half of the home. So what we will do, we will again erect another air terminal in order to protect other part of my home. So this zone is overlapping with this zone, and so we can say that my home is completely protected. So this is the formula to protect the equipment or home through the protection angle method. You will get more better understanding when we will go for the numeric calculation for the protection angle method. As we have seen, different rolling sphere radius for different class of protection in the rolling sphere method. In the mesh method also we have seen that the mesh sizes is different for the different class of protection. In same way, for different class of protection, here you can see class 1, class 2, class 3 and class 4. For different class, there is a different angle of protection. Which is depend on the height. This I very deeply explain in the part 2 video when I discuss about the different method involved for the lightning protection system. Okay, but overview I am giving you. For different class of protection, there is a different graph for the protection angle based on the height of the air terminal or the resultant height of the air terminal. Now this graph is also tabulated in the IEC standard. For example, for 3 meter of rod for class 2 protection, the angle is 70.1 degree and the radius of the cone is 8.3. What does it mean? This will be very clear from this picture. As we have seen in the table, the height of the air terminal is 3 meter, which is this height is 3 meter. Based on the protection angle graph or the table provided by IEC, the protection angle is 70.1. So the radius of this imaginary cone is 8.3 meter, means this distance is 8.3 meter. If you can imagine the dia, it will be double of this, that will be equal to 16.6 meter. Hope you are very clear. So based on different length of the air terminal, like 1 meter, 2 meter, 3 meter, so on till 36 meter, they have given for different protection angle and different radius of the cone for different class of protection. As our class of protection is class 2, so we have seen for 3 meter of air terminal, the protection angle is 70.1 degree and the radius of the protection zone is 8.3 meter. In same way, for 19 meter air terminal rod for class 2 protection, the degree protection angle is 39.2 degree and the radius of the protection zone is 15.5 meter. So you can see for every length of the air terminal for different classes of the lightning protection system, protection angle degree and the radius of the protection zone is given. Now let us move to the other point. Here you see there is a air terminal here which having a height of h1. So this is the reference plane for this air terminal. For this reference plane, the protection angle is alpha 1. But for same air terminal, the height this time is not h1 but it is h1 plus h, which is equal to h2. So the resultant height of the air terminal is this one, h2. So based on this h2, the protection angle is no more alpha 1 but is alpha 2. So what we noticed here, for same air terminal, if the reference plane changes, the angle of protection also changes. Why? Because the height of the resultant air terminal changes. For example, the height of the air terminal is 1.5 meter. But as it is installed on a parapet which having a height of 1.5 meter, so the resultant height of the air terminal with this reference plane is 3 meter. So the h1 will be 3 meter. And with this reference, the height of the resultant height of the air terminal will be height of the air terminal plus height of the parapet plus height of the building, which is equal to 19.3 meter. So remember it, with this plane the height is 3 meter, with this plane the height is 19.3 meter. If we will refer the table provided by the IEC for the different protection angle, we will come to know the alpha 1 and alpha 2. So let us check. So for 3 meter height, what would be the alpha 1, and for 19.3 meter height, what would be alpha 2? So here is the table. For 3 meter, for class 2 protection, the protection angle is 70.1 degree, and for 19.3 meter, which is approximately equal to 19, the protection angle is 39.2 degree. So this we have reflected here. Alpha 1 for 3 meter height, the angle of protection is 70.1, and alpha 2 for height 19.3 meter is 39.1 degree. Hope you are very clear with this point. So this is very important point, that for the different reference plane, for the same air terminal, the angle of protection can be different. Okay, now we will focus on this image. Suppose I have installed one lighting protection air terminal. Okay, with this reference plane, it is giving angle of protection as alpha 1, and as per this plane, it is giving the angle of protection is alpha 2. When we draw a line with same angle alpha 1 and alpha 2, we notice that some part of the building is outside of the protection zone. So we can say that this zone is unprotected, and whichever line is coming under the protection zone is called protected zone. So based on this concept, we will calculate and design the lightning protection system as per protection angle method. Hope you clearly got the concept behind the protection angle method. This is very important, because in order to design any project based on protection angle method, the concept behind it to be very clear. So suppose this is the building, okay, and we have to design the lightning protection system based on protection angle method. So we have to calculate the number of air terminal which is giving protection to this structure completely. So how we will do? We will see it here. Suppose I have a structure of 16.30 meter, okay, and above the structure there is a parapet, and we install one air terminal of 1.5 meter. The parapet structure is also 1.5 meter. So the resultant height of this air terminal with reference to this plane is 3 meter. So H1 is 3 meter. Based on the height of the air terminal, that is 3 meter, and the class of protection is class 2, we have to check the protection angle method based on the graph provided by IEC. As we have seen in the graph that it is 70.1 degree, which we have seen earlier. Okay, and with this reference plane, we have the resultant height is 19.3 meter. When we refer the IEC standard protection angle graph, we came to know that the angle is 39.1 degree. So we now have the angle, that is alpha 1 and alpha 2, which is 70.1 degree and 39.1 degree. Now we will consider this triangle. Okay, this triangle, we will consider this triangle. Okay, here this is this triangle. The protection angle is 70.1 degree. The height of the air terminal, resultant air terminal, is 3 meter. So for this right angle triangle, for this angle, this is the perpendicular, this is the hypotenuse, and this is the base, right? If the angle will be here, so for this angle, this will be the base and this will be the perpendicular. But our angle of interest is this one, the protection angle, which is 70.1 degree. So for this angle, this will be the perpendicular and this will be the base. So based on the simple trigonometrical formula, tan theta is equal to perpendicular by base. So we don't know the dimension of perpendicular, but we know the base height, that is 3 meter. We know the protection angle, that is 70.1. So tan 70.1 is equal to perpendicular by 3. If you will check through the scientific calculator what is the value of tan 70.1, it came as 2.77 into 3. So the perpendicular came as 8.31. So in this diagram, this distance is 8.31 meter. Okay, in same way we have to calculate what would be this distance when the protection angle is 39.1 and the height is 19.3 meter. So let us calculate. So we have to analyze this triangle, this right angle triangle. So let us analyze. This is the triangle where the protection angle is 39.1 meter. The height is 19.3. So based on this angle, okay, this is the base and this is the perpendicular. So as per the trigonometrical formula, tan is equal to perpendicular by base. So tan 39.1 is equal to perpendicular, which we don't know the dimension, but base we know, that is 19.3 meter. So if we will go and calculate 39.1 tan is equal to 0.81 into 19.3, so perpendicular came as 15.6 meter. So in the photo it will be how much? 15.6 meter. So it will be 15.6 meter. From above calculation, we came to know that one air terminal is giving protection, one side is equal to 8.3 meter and other side also 8.3 meter. So one air terminal is covering approximate 16.6 meter area. Okay. So as we have taken previously worker accommodation example, so in this method also we will take a worker accommodation example and we will calculate the number of air terminals as per protection angle method. So the length of the building is 73.6 meter and the width of the building is 13.6 meter and the height of the building is 16.30 meter. So how many number of rod required along the length of the building? As one air terminal giving 8.3 meter protection in one side, so in two side it will give approximate 16.6 meter coverage. So along the length of the building divided by the coverage, that is 16.6 meters. So it came approximate 4.4 rods. And the number of rods along the width of the building, that is the width of the building divided by the length covered by the air terminals, that is 16.6. So we got 0.81, so it is approximately 1 rod, and here it is approximately 4 rod or 5 rod, you can consider. I am considering 4 rod because here I overestimated and here I will underestimate it, but you can go with 5 rod and 1 rod also. Okay. Now, so we came to know along the length of the building we required 4 air terminals. So 1, 2, 3, 4. In this side also along the length of the building 4 rod, 1, 2, 3, 4. Along the width of the building 2 rods, 2 air terminal. So we calculated the number of air terminals required for a particular project based on the protection angle method. Here I want to highlight one more point, that the down conductor which I discussed in the last class, based on the different classes of protection, there will be a different number, there will be a distance between the down conductor. For class 1, it is the down conductor distance should be 10 meter. For class 2, it also will be 10 meter. For class 3, it should be 15 meter. And for class 4, it is 20 meter. Based on that, we know the spacing required between the down conductor is 10 meter as our class of protection is 2. And the building perimeter is 177.2 meter, which is 2 into length plus width, right? So the spacing required is 10 meter. The perimeter of the building is 177.2 meter. So we will come to know the required down conductor is 177.2 divided by 10, which is equal to approximate 18 down conductor. So we have to use 18 down conductor. So here you see we have calculated the number of air terminals, which is equal to 10, 8 along the widths, 4 along the widths both sides, so 8, and 1 along the width, which is equal to 1, 1, so 2. This green color is the down conductor. So we calculated 18 down conductor. So let us count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17 and 18. So total 18 down conductor. So how many earth pits we require? It is equal to the number of down conductor. So each down conductor will connect to the respective earth pit. So how many earth pit is equal to the number of down conductor? The down conductor quantity is 18. So the earth pit quantity will be also 18. If you will count, it will be 18. So this is our project. We calculated the number of air terminal based on the protection angle method, which is equal to, total number is equal to 10. 4 along this length, 4 along opposite side length, 2 along the widths, 1 this side and 1 that side. We calculated the number of down conductor, which is equal to 18, which has to be divided equally around the perimeter of the building. The number of earth pits will be equal to the number of down conductor, which is equal to 18. So this will be 18 earth pits. Okay, these all earth pit will be looped through a earthing wire of minimum 70 square mm. Hope you are very clear with the designing of lightning protection system based on the protection angle method. Let us compare these three methods, that is the protection angle method, mesh method and rolling sphere method. The protection angle method is used for simple construction, okay, but for complex construction we cannot go for protection angle method, and for plain structure don't go for protection angle method. Mesh method we have to go for the plain structure, but it is not useful for complex shape structures as well as for simple structures. Rolling sphere method is a universal method. We can go for simple structure method, complex structure method and the plain structure. Here there is very important point to be noted, which is mentioned here for the protection angle method. Protection angle method cannot be applicable for those projects whose structure height is greater than the radius of the rolling sphere method for a selected protection level of LPS. What does it mean? Suppose this building is of 80 meter, okay, and we selected the class of this protection to be class 2. Okay, so the rolling sphere radius will be 30 meter. As we seen that the structure height is greater than the rolling sphere method. In such cases we cannot go for the protection angle method. For such structure we cannot go for the protection angle method. I will show you through the graph to better understand this one. Let us analyze the graph of class 1 protection. Here you see for a building of 17.8 meter we have one intersection point with the graph 1, okay, class 1 protection graph. But any building beyond 20 meter, let's say it's 25 meter, it is not intersecting with the class 1 graph. It is intersecting with class 2, class 3 and class 4. So we will not get any protection angle for the class 1 protection which having a structure greater than 20 meter. In same way, let us analyze class 2 graph. So this is the class 2 graph, okay. For 25 meter height of the structure, it is intersecting with the class 2 graph. But any structure beyond 30 meter, let's say 35 meter, it is not intersecting with the class 2 protection graph. Okay, it means the class 2 protection method for a building greater than 30 meter cannot be applicable. So this point was mentioned in that comparison chart. What that comparison chart mentioned? That suppose, as we know that for rolling sphere method, for class 1 it is 20 meter, class 2 it is 30 meter, class 3 it is 45 meter and class 4 it is 60 meter. Okay, so for class 1 20 meter. So protection angle method for class 1 which having a structure of 20 meter is applicable. Beyond this one it is not applicable. For class 2 protection we can apply protection angle method less than or equal to 30 meter, but beyond we cannot apply. For class 3 we can apply protection angle method till 45 meter height structure. Beyond this one we cannot apply because it will not intersect with the class 3 protection graph. In same way, for class 4 protection we can apply protection method till 60 meter height of the structure. Beyond this one we cannot apply. Moreover to that, any structure which is having greater than 60 meter height, we cannot apply the protection angle method. Hope you are very clear with this point. Now let us analyze the protection angle method in order to protect the equipment installed over the roof, in order to protect that equipment from the lightning strike. So suppose this is the equipment, outdoor unit is installed over the roof, and we have to decide this air terminal which is having the spacing from the equipment itself is S, and based on the protection class there will be an angle which is dependent on the selected height of the air terminal. So how to calculate these all things in order to know that our equipment is protected from the lightning strike or not based on the protection angle method. So let us understand this topic. Now we have to go with the simple mathematical calculation. Suppose our air terminal rod is 1.5 meter height, okay. One equipment is placed which is 0.5 meter space between the air terminal and the equipment, okay. The equipment width is 0.75 meter. Hope you are very clear. This we know from the physical measurement at site. The height of the air terminal, the spacing between the air terminals and the equipment dimension itself. Now let us analyze a triangle OEF, which is OEF. So it will be this triangle. Okay. Now, as we know, the height of the air terminal is 1.5 meter. The spacing between the air terminal and the equipment is 0.5 meter, and the equipment with itself is 0.75 meter. So when we will refer the protection angle graph from the IEC with this reference plane, we will get to know that this protection angle will be 73 degree for the air terminal rod of height 75 meter. I will show you later, but just consider that the protection angle will be 73 degree. So tan theta is equal to perpendicular by base, right? So this is the perpendicular EF. I mentioned EF. What is the base? OE. So I mentioned here OE. So tan theta, that is equal to tan 73, is equal to EF by base. Base how much? It's a height of the air terminal, which is equal to 1.5, which I mentioned here. Tan 73 is equal to 3.72. You can calculate it through the scientific calculator. Into 1.5 will be equal to EF. This distance EF is equal to 4.9. Okay. Now we have to analyze this triangle BDF. We have to analyze this triangle DBF. Okay, DBF. So for this, if this is 73 degree, so it is a perpendicular same triangle, so this will be also 73 degree. It's very clear. It's a simple maths, right? So tan theta 1 is equal to perpendicular divided by base. So what is perpendicular? It is BF. BF is the perpendicular and base is the BD. Okay, I mentioned here. We know tan 73 against 3.27 BF. BF is equal to how much? What is BF? BF is equal to EF minus EB, right? BF is equal to EF minus EB. So EF we already calculated here. EF we calculated as 4.9. So here I mentioned EF is equal to 4.9 and EB is equal to S plus the width of the equipment, that is 0.25 into plus 0.75 is equal to 1. So BF came as 3.9. So we place this 3.9 here. BD divided by BD. So BD came as 1.19. Okay, 1.19. BD came as 1.19. Now our equipment height is 1 meter. Let us say it is 1 meter. Okay, 1 meter, and the BD came as 1.19 meter. So as our equipment height is lesser than the BD height, it means our equipment is under this protection zone. For example, if our BD height came not as 1.19, it came as 0.8. For example, it means our equipment is 1 meter and BD is equal to 0.8. It means our equipment is not safe as some portion of this equipment is crossing the protection zone. In that case, what we have to do? Either we have to increase the length of the air terminal, okay, or we have to put concrete block of 0.5 meter, so the overall length of the air terminal increase from 1.5 to 2 meter. So in that way we can provide protection to the equipment. I hope you clearly understand what is the protection angle method, how it is a simple mathematical derives of the rolling sphere method, and how to calculate the lighting protection system, how to do the designing for the lightning protection system as per the protection angle method, and how to do the protection for the equipment installed in the roof from the lightning strike from the protection angle method. If you really like this video, then please give thumbs up and subscribe to my channel. Don't forget to press the bell icon for future videos update. Most important, please share this video with your electrical friends. We will meet in any other video. Till then, take care, keep learning, and bye-bye. Thank you so much.